Asking. All right, before we handle your questions from the homework assignment, I want to make sure everybody understands what they did wrong on the quiz, because as you know, you will see these problems again very soon coming to a movie theater near you. So number one, you need to combine the like terms there. 4x plus x makes 5x. Then you still have a plus 2. That makes that a linear binomial. Most common mistake there, was that students wanted to say that it was constant. But even when you have 5x plus 2, you might look at that and say the exponent is 0 because there is no exponent written, but the exponent is actually 1. We just don't write it when it's to the first power. So that makes that a linear binomial, okay? Then most of you did much better on the second one, but remember that to put it in standard form, you have to write it in descending order of exponents. So your first task was to rewrite it as negative 4x cubed plus x squared plus 3x. Some of you wanted to leave that negative where it was, but the negative goes with the 4x cubed and moves to the front. And then that makes that a cubic trinomial, okay? All right, then for 2a, since the lead coefficient is positive and the degree is 4, which is even, that makes that an up. For 2b, you have to recognize that it's actually the negative 3x cubed that's the lead coefficient, because that has the highest exponent with it. And so since that one is negative and the degree is 3, which is odd, that makes that an up, down. And then we had a number of little math mistakes on number 3. From negative 16 to 1 is actually up 17. Then this is up 3. Then this is up 1. Then that's up 11. So since those first differences are not all the same, it's not linear. Then if I look at the second differences, this is down 14. This is down 2, and this is up 10. Also not the same, so it's not second degree. But then when you look at the third differences, negative 14 to negative 2 is up 12, as is negative 2 to 10. So since these are the same, that means that the original polynomial must be third degree. Okay? Any questions on any of those? So as I mentioned, when you guys have a quiz again tomorrow, there'll be some of these problems on there to start, and then some of what we're doing in this section. So make sure you understand this as we move forward, okay? All right, we guys get out your assignments from yesterday and let me know what questions I can help you with, Ashlyn. 21? 12. Okay. All right, so yes, good. Thank you for asking that question. 12, you are asked to factor. This is a challenging one. You know, this is in that category where very few of you will take this with you when you move on to other advanced math classes. So if you don't entirely understand it, don't stress out. Don't be a Sydney. But still try, okay? The first step is pretty straightforward. What can I factor out of all three of those terms? Yeah, not only can I factor a 3, right, but I can also factor out an x. So that would leave me with 3x squared plus 2x minus 1, okay? And honestly, if we were to come across this in like pre-calculus or calculus, we would probably just go the quadratic formula from there. But just for funnies, we'll practice that other factoring method, which you have to use when the lead coefficient is not 1. So instead of looking for two numbers that multiply together to be negative 1 and add to be 2, I have to take these two numbers and multiply them together first. And that tells me that I'm actually looking for two numbers that multiply together to be negative 3 and add to be 2. What are those two numbers? No. Negative 1 and 3. Good. So that tells me how I'm going to take this middle term and break it up into two pieces. So I'm going to rewrite 2x as plus 3x minus x minus 1. So this 2x is now broken up into 3x and negative x, and those things come from the 3 and the negative 1. Okay? And so what I'm going to do from there is I'm going to look at this as two separate problems. What can I factor out of 3x squared plus 3x? 3x. If I factor 3x out of 3x squared, what am I left with? Amy, I'm looking at you. Good. And if I factor 3x out of 3x, then I'm left with 1. Okay? What can I factor out of negative x minus 1? Negative 1. And when I do that, what am I left with? X plus 1. Okay? And then the fact that these two came out to be the same is not a coincidence. That means that we've done this correctly. So we still have the 3x, the original 3x that we factored out in the very beginning. Then I'm going to factor an x plus 1 out of both of these. So if I factor an x plus 1 out of this, I'm left with if I factor an x plus 1 out of this, what am I left with? 3x. And if I factor an x plus 1 out of this, I'm left with negative 1. Okay? So that final factorization is 3x times x plus 1 times 3x minus 1. If you got that on your own, really good job. I'd be surprised if there's more than 2 or 3 students in class that were able to do that before I gave them. Yeah, I don't know if anybody got that right. Okay, that's a tough one. Good question, Ashlyn. Okay, what else can I help you with? Brianna? Which one? 13. Can you tell me what number 13 says? Y equals x minus 1. Okay, and what are we supposed to do with that? Oh, okay, sweet. So what are the zeros? Okay, so that means I know that it's going to cross the x-axis at 1 and at negative 2, right? So then if I just multiply these first two terms together, what do I get? X squared. And so since that's positive and even, or since we just know it's going to be a parabola, yeah, it's going to be up and up. So a rough sketch of the graph would look like that. Okay? Okay, yes. Number 10. Okay, you'll have to tell me what that is too. X what? Oh yeah, okay. So what can you factor out of that? An x. And so that leaves you x squared minus 36. Okay. Now I can factor x squared minus 36. I'm looking for two numbers that multiply together to be negative 36 and add to be 0. 6 and negative 6. Good. So this is x plus 6, x minus 6. This has a special name. It's called the difference of two squares. So you can factor it into plus or minus the same thing. Okay? Yeah. No. Other questions? Chris? Question? Which one? 25? Yeah. Yeah. What does number 19 say, Sydney? Sorry, I don't, my flip chart I just made the multiples of 3 and then I gave you guys a different assignment, so. Yep. Hallelujah. You don't. I mean, not really. Okay, so this is totally fine. Okay, but Sydney, since she is above and beyond, go the extra mile, she says, it says a polynomial in standard form. This clearly is not a polynomial in standard form. So the way that you would get it in standard form is you multiply the whole thing out. Okay, so I started out by foiling these two things. First times first is x squared. Inside is negative 5x, outside is negative 6x, so that combines to be negative 11x. And then last times last is positive 30. Okay, then I went through and I multiplied each one of these terms by x, so that changed it to x cubed minus 11x squared plus 30x. Then I multiplied each one by negative 7, and then I combined those like terms and got my final answer. But this is totally fine. Yeah, this would be like for extra credit to get it all the way to that. Yeah, that's an arrow. It's like the worst arrow I've ever drawn in my life, but yes, it's an arrow. Yeah. How's that? Brianna? Slightly better now? Okay. Yeah, it was supposed to be an arrow. Okay, Callista, what are the zeros? Awesome. Okay, so what that tells us is that, bless you, our graph is going to cross the x-axis at each one of those points. So I'm going to put a dot at 1, 2, 3, 4, negative 5. I'm going to put a dot at 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to put a dot at 0. Okay? So the question is my graph down, up? Or is it up, down? Okay? Yeah, it's down on the left and up on the right. And the reason that you know that is because if you multiply all three of those things together, you end up with x cubed, which is positive odd, which means down, up. Alexandria? What just happened? First, I disrespect your Christmas tree. Then, I don't let you use the bathroom. First, I let Peyton go. So that's like 3 disrespects in a row. I think I can get to like 6 or 7 by the end of the period. That's my goal. Chris? What's that? 25? Sophie? Go ahead. Okay, 25, what does it say? Sydney, what does number 25 say? 0, 0, 2, and 3. All right, this is a good one to end on, because this is what we're going to talk about today, is what happens when 2 of the zeros are the same. Right. So technically, if I wanted to write this out, it would be x minus 0 times x minus 0 times x minus 2 times x minus 3. Okay? But x minus 0 is just really x, right? You don't need the 0 in there. And then x times x is x squared. So I'm going to write it as x squared times x minus 2 times x minus 3. Okay? Okay. Anna, did you express some frustration because I indicated this was the last question that I was going to answer? Yeah, too bad. What's your question? 16. You're going to have to read that one to me also. On your homework? I think so, yeah. What does number 16 say, Anna? Sydney, what does number 16 say? Times x minus 2 times x what? Okay. So what are the zeros? Okay. So then if I want to graph this, it's going to go through -1, it's going to go through 2, and it's going to go through 3. And pretty much since, what? Oh, didn't it say to sketch a graph also? Yeah. Okay, and then pretty much since all of the x's are positive and it's another x cubed, it's going to have the same shape as the other ones that we've done. This is positive x, and positive x. Okay? I like how you just immediately started raging on that. Wait, all the x's are positive? What does that mean? How can you possibly say that? If there was a negative x in here somewhere, then that would flip it over, yeah, and then it would start at the top and go down. Yeah, yeah. Okay, we can. All right, so yesterday I left you with the burning question. What do you do to the graph when both of the zeros are the same? And if that kept you up last night because you just like couldn't sleep because you just had to figure this out, then I apologize, okay? Yeah, what happens with this is if our zeros are -2 and -2, then that means we have to include that in the factored form twice. And so Emma correctly says that an easier way for us to write that is as x plus 2 squared. All right? So that's the easy part, and we kind of talked about that just a couple minutes ago when we had 0 as a 0 twice, and we did x minus 0 times x minus 0, which someone pointed out is the same as x squared. But what we didn't get into a discussion about is what that does to the graph, okay? How can you go through x equals -2 twice, okay? So what we're going to do to figure that out is we're going to get some help from some technology. And so I'm going to go ahead and show you what the graph of x plus 2 squared times x minus 2 times x minus 3, okay? So the way that that looks is, as we would expect, the graph goes through the x-axis at x equals 2 and also at x equals 3. But at x equals -2, something crazy happens. The graph doesn't actually go through the x-axis at that point. It just goes down and touches the x-axis and then turns around and goes back the other way, okay? Why? Can anyone say why it behaves that way at that point? Perhaps Emma might know. And what does an x squared graph usually look like? A parabola, and so since this is squared, then this takes on the shape of a little mini parabola at that point, okay? And so if I turn this upside down by throwing a negative in front, it would do the same thing. It would just do it from the opposite direction, okay? And so what that's called is that's called a multiplicity or a multiple zero, okay? And that's just a simple name for a zero that comes up more than once, all right? And knowing that will be important to the work that we do together next year and for the lucky 5 sophomores in here the year after that. But for right now, all I want you to do is be able to tell me if it is a multiple zero or not, and then if it goes through the x-axis or if it just touches it, okay? And so the cheat for that is if it's an even multiplicity, that means that it just touches the x-axis. But if it is an odd multiplicity, then that means it crosses the x-axis, okay? So in other words, if you have a 0 that comes up twice, or if you have a 0 that comes up 4 times, or if you have a 0 that comes up 6 times, or if you have a 0 that comes up 8 times, or if you have a 0 that comes up 10 times, or if you have a 0 that comes up 12 times, or if you have a 0 that comes up 14 times, I just have to do this for 20 more minutes, or if you have a 0 that comes, okay, all of those, since they're even numbers, are just going to touch the x-axis and then go back the same direction they came from. It just, oh, I forgot a word there. Sorry. It just touches the x-axis, okay? If it's an odd multiplicity, then it goes through it crosses the x-axis, okay? And like I said, that is going to be important to us. That is going to be important to us farther down the road. It just touches the x-axis or it crosses the x-axis. Ashlyn? No. Yeah, that's bad handwriting, huh? Yeah, yes. Shh. Say that again? Yeah, it doesn't matter what the number is, it matters what the multiplicity is. Yeah. Yeah. Okay, so that adds a new element for us in our factoring. So if I factor x to the fourth minus 2x cubed minus 8x squared, yeah. What can I factor out of those three terms first? Not just an x, but a x squared, right? Because in this case, the lowest exponent is squared. So I'm going to factor an x squared out of that. If I factor an x squared out of x to the fourth, what's left? X squared. If I factor an x squared out of 2x cubed, what's left? 2x. And if I factor an x squared out of negative 8x squared, then I get negative 8. Okay? So that time, instead of just factoring an x out as our first step, we were able to factor an x squared out. Now I can factor what's left inside the parentheses. Chris? X plus 2 and x minus 4. Yeah, good. Okay. Okay, so now we have it completely factored. So what are the three zeros? Then don't say anything. 0, negative 2, and positive 4. Okay, what is the multiplicity of 0? How many times does that show up? Twice, because it comes from this x squared. So this has a multiplicity of 2. How many times does negative 2 show up? Just the once, because these parentheses aren't being squared or cubed or anything like that. So that's a multiplicity of 1. And then this one good also has a multiplicity of 1. So what will happen to the graph at x equals 2? Will it go through the x-axis or will it just touch it? Okay, so this just touches. What about these two? Okay, good. This one crosses and this one also crosses, okay? And if we want to, we will here just a second. I'll show you the graph of the original polynomial so you can see that we're correct. Abby? Because this one, the x equals 0 came from this right here, from the x squared. And since that has a squared in it, it has a multiplicity of 2. Okay? All right, so let's graph the original thing. so let's go x to the fourth. What was the next part? Minus 2x to the third. And then what? Thank you. Minus 8x squared. Okay, so you can see that the graph is behaving like we would have expected it to. It's going through the graph at -2 and at 4 because both of those zeros had an odd multiplicity. But then at x equals 0, it just goes up and touches the graph because that one had a multiplicity of 2. Okay? All right, so will you all try this one on your own? Factor this. Say what the multiplicities are at each one of the zeros, and then use that to say what will happen to the graph at that point. Okay, Emma, can you start by factoring it? Yep. And what are you left with when you factor that x out? Okay, good. So first step, you factor out an x, and then what did you factor? X squared minus 4x plus 4 and 2. -2 and -2, yeah. Okay. So hopefully that's what you guys all got for the first step when you factored it. All right, so now that we have it in factored form, we can use that to identify the zeros. Sage, what are the 2 zeros of this function? Yeah. But not -2 because I want the number that will make this equal to 0. Right, 2 because 2 minus 2 is 0. Okay, but since that comes up twice in both of these parentheses, we could write this as x times x minus 2 squared. You don't have to, but you do have to recognize that since it does come up twice, it's a multiplicity of 2. Okay, and then what's the other 0 that will we get from that right there? 0. Good. Okay. And that's just a multiplicity of 1 because that wasn't squared or anything weird. All right, so now that we know that, because if this is 0, then that'll make the whole thing be 0. Right, there is 2x equals 2, so I just wrote that as multiplicity 2 instead of writing them both out. Okay. Vili, what will happen at the graph at x equals 2? Right, so it's a parabola thingy, so that means it just touches the x-axis. And what will happen at x equals 0? It will cross the x-axis. Yep. You're welcome. That's it. Me? No.